Now we're discussing about the topic cyclotron. Cyclotron is a cyclic accelerator. A cyclotron is an equipment used for accelerating positively charged particles like proton, deuteron, alpha particle and heavier ions to desired velocities. It consists of two flat semicircular boxes in the shape of the letter D and hence called Ds. Surrounded by a closed evacuated vessel, the Ds are placed in between the pole pieces of a dipole magnet and radio frequency potential of 10 to 20 MHz frequency is applied between the Ds. At center of the disk, a source S of positively charged ions of mass m provide a beam of ions of a suitable initial velocity v in the plane of the disk. The presence of the magnetic field B forces these ions to move along a circular trajectory of radius r given by Lorentz force equation. BQV is equal to mv square by r. Then BQ is equal to mv by r. Then r is equal to mv by BQ. When the ions pass through the space in between the disks in one direction, suppose that the radio frequency potential on the disks are such that the disk towards which the ions are moving is at negative maximum with respect to the other. The ions will be accelerated and thus gain in energy by an amount qvm. Inside the D, the ions move through a region free of electric field. Since a field does not exist inside a hollow conductor, their velocity remains a constant until they reach the gap between the disks. At the next gap, the ions receive an additional energy increment if the phase of the RF field is adjusted, so that at the instant the ions reach the next gap, the RF voltage has advanced by exactly 180 degree in phase. The process is repeated. The time taken by the ions to traverse the semicircular trajectory inside a D is small t is equal to pi r by v. Then r is equal to mv by bq. Then small t is equal to pi mv by bqv, that's equal to pi m by bq. The increase in the velocity of the ions is compensated by the increase in the path length inside the D, and therefore the time of transverse inside a D is a constant. The condition to be satisfied for the ions to receive acceleration at the gaps is that within the time interval small t, the RF field exactly reverses its polarity. Small t should be just equal to 1/2 of the RF period. Small t is equal to tau by 2. Then the angular frequency of the RF omega equal to qb by m. The ions will always receive the same acceleration whenever they reach the gap between the disks. The ion's energy consequently continually increases until it reaches the periphery of the disk. At this point, they are deflected away from their circular trajectory by an electric field and allowed to bombard a suitable target for carrying out the required studies. This is the schematic representation of cyclotron. Top view ലാണ്. അതായത് 2 ഡീസ് ഉണ്ട്, അതേപോലെ ഒരു ടാർഗറ്റ്, ഒരു ഡിഫ്ലക്റ്റർ പ്ലേറ്റ്, ദെൻ സെൻറ്റർ എ സോഴ്സ്, ഒരു RF പൊട്ടൻഷ്യൽ കൊടുത്തിട്ടുണ്ട്. RF പൊട്ടൻഷ്യൽ കൊടുക്കുമ്പോൾ മാഗ്നറ്റിക് ഫീൽഡ് പ്രൊഡ്യൂസ് ചെയ്യും. ദെൻ ദർ ഈസ് എൻ ആക്സിലറേറ്റിംഗ് ഗ്യാപ്പ്, നോർത്ത് സൗത്ത് 2 പോൾ പീസസ്, അറ്റ് സെൻറ്റർ അയോൺ സോഴ്സ്, then 2 Ds. Then maximum energy of positive ion. Let V naught R naught be the maximum velocity and maximum radius of circular path followed by positive ion in cyclotron. M V naught square by R naught is equal to BQ V naught. Then V naught is equal to BQ R naught by M. Then the maximum kinetic energy is equal to half M V naught square, that is equal to half M BQ R naught by M whole square, that's equal to B square Q square R naught square by 2M. Then B is equal to 16 Gauss, then R is equal to 50 centimeter, then E is equal to 31 mega electron volt, then F is equal to omega by 2 pi, that's equal to 24.4 megahertz. Then the principle of cyclotron. It is based on the fact that a positively charged particles can be accelerated to sufficiently high energy with the help of smaller values of oscillating electric field by making it to cross the same electric field time and again with the use of strong magnetic field. Then the cyclotron frequency. If capital T is the time period of oscillating electric field, then capital T is equal to 2 into small t. Then capital T is equal to 2 pi m by bq. Then the cyclotron frequency mu is equal to capital 1 by t. That's equal to bq by 2a pi m. Then MC Millen suggested that if the oscillation frequency is continuously adjusted to coincide with the decreasing frequency of revolution of the ions, the condition of phase stability can be achieved. Let us suppose that under normal conditions, uh, under normal conditions, the ions receive the acceleration at time t0. If the ions always remains in phase, they will arrive at the next day at the same relative time instant t0. During the next half cycle, they will thus gain the same increment in energy if the ions arrive at the d too late as at time t1. The accelerating potential will have decreased and the ions will not be getting the full increment in energy delta E and thereby in mass delta M. The time required to traverse the path within the D is now less and the ions arrive at the next gap in time to receive the regular increments in energy and mass. Similarly, if in one half cycle of the ions arrive at the D too early, as at time t2, they receive larger increment in energy and mass. The time of arrival at the next D will be delayed to coincide with T0 so that the normal acceleration will be imparted. The revolution of the ions is thus automatically adjusted with the changing frequency of RF. This principle is termed as the synchrotron. Then, limitations of the cyclotron. Not suitable for neutral particles. Can be accelerated heavy particles only. When ion is accelerated by the cyclotron, then speed of ion goes on increasing and finally when speed of ion becomes comparable to the speed of light c, then mass of ion changes accordingly, then m is equal to m0 by root of 1 minus v square by c square. Now time taken by the ion to complete semicircular path inside d is small t, that's equal to pi m by bq. Then m is equal to m0 by root 1 minus v square by c square. Then small t is equal to pi by bq into m0 by root of 1 minus v square by c square. Now as v increases, v by c decreases as a result of which small t increases. So, ion will take more time to describe semicircular path inside D. So we can conclude that with the cyclotron ion can be accelerated up to a certain limit. Thank you.